All right, so welcome back. Now in this video, we're concerned with moving the character, and this is going to involve axis mappings. We're going to use axis mappings to get input from the player to add movement input to the character. So let's talk about axis mappings. Axis mappings are what we use to retrieve input from a player, and by input I mean pressing a key or moving the mouse. When we perform these actions, the engine has a way of processing that information in a way that we can use to perform actions like move characters. Now, these axis mappings are set up in our project settings. We can reach the project settings by going up to Edit and clicking on Project Settings. And here in Project Settings, there are a ton of different settings for our project. The one we're interested in is under the Engine section, and it's called Input. If we click on Input, we'll see that here under Bindings, we have Action Mappings and Axis Mappings. We're interested in axis mappings. We can add an axis mapping by clicking the plus icon. And now we see a drop-down, and if we expand it, we have a new axis mapping. And by default, it's called New Axis Mapping 0. But we'd like to have a descriptive name so we know what this axis mapping is used for. We're going to call this axis mapping Move Forward. And as soon as we rename it, we see that there is another drop-down. And if we click the drop-down, we can choose any number of input types for this axis mapping. Now, I'd like to be able to press the W key and move the character forward. So if I click the drop-down under Keyboard, I see all of the keys available for this axis mapping. And if I select W, then I've now linked the W key up to this Move Forward axis mapping. Now, there's an icon here that looks like keyboard keys, and if we click on that and press a particular key on the keyboard, then it will automatically assign that key. So you could simply click on this and press the W key, and now the W key is linked to the Move Forward axis mapping. Now, next to the drop-down is a scale, and the scale has a number. By default, it's set to 1. We'll talk about this scale value in a moment. Now, the reason we're making an axis mapping is so that we can do something when we press the W key. Now, we can associate multiple inputs to a particular axis mapping. For example, if I press the plus icon next to Move Forward, I get another option for an input. And if I click the icon that looks like keyboard keys and press the S key, now the W and S keys are associated with Move Forward. And I'd like to take this scale value here for S and change it to -1. So why am I doing this? Now, to understand why I changed the scale value to -1 for the S key, we have to understand how axis mappings work. So we have this axis mapping, and we called it Move Forward. And we know that we have two keys linked to it, the W key and the S key, and that these keys have their own scale values. W has 1 and S has -1. So this is how an axis mapping works. As soon as we created the Move Forward axis mapping, an event was created in Unreal Engine called Input Axis Move Forward. Events are a lot like functions in programming. Somewhere, something calls the function or event, and any blueprint nodes that we hook up to the output execution pin on this Move Forward event will be executed. So we can access this Input Axis Move Forward event from within our character blueprint and plug up any sort of logic that we'd like to be performed when this Move Forward event is fired off. Now, by default, axis mappings are fired off every single frame of the game, and they have a return value. This means that when Move Forward is fired off, a value is provided every single frame, and that value depends on the keys that we're pressing, specifically the keys that are linked to the axis mapping. For example, let's say we're pressing the W key. Then every single frame, this Move Forward event will provide a numerical value, and that value will be 1.0. Now, if instead we're pressing the S key, then the Move Forward event will provide an output value of -1.0. And these values will change depending on the scale that we have set for those particular keys. If we changed the W scale to, say, 2.0, then move forward will provide a value of 2.0 every single frame of the game. Now, axis mappings work in such a way that they are added together. So if W and S are being pressed simultaneously, 1.0 and negative 1.0 will cancel each other out, and move forward will provide a value of 0. And if we're not pressing either key, move forward will also provide a value of 0. So let's see how this works in Unreal Engine. So I'm back here in Project Settings, and I have move forward linked to W and S with their associated scale values. Now there's no save button. As soon as we change these, they're automatically added to the project, so we can simply close Project Settings. Now let's go to FPS Character and open the character blueprint. We're interested in the event that was automatically created as soon as we set up our axis mapping move forward. We can access that by right-clicking and typing move forward. Now we see two things that pop up, a move forward event under axis events and another move forward under axis values. We want the move forward axis event. And if we click on this, we'll see something that looks a lot like the other events that the character blueprint starts off with by default. So this is the move forward event we were talking about. Anything we hook up to this event will be fired off every single frame since axis mapping events are fired every frame. Now we can see the value of this output called axis value, and we can do this using a print string node. So if I click on the output execution pin and drag off a wire, when I release the mouse button, I get a search menu and I can type print string, and I can select print string and get a print string node. And if we click on the output called axis value and we drag this in to the input called inString, we have this convert float to string node, which will automatically convert from a float to a string. If I compile and hit play, I now see the value 0 printed to the screen. Now I'm going to press the W key, and as soon as I do, I see that 1 is printed to the screen as long as I'm holding down W. Now if I release, we see 0, and if I press S, we see -1. So now we see how this axis mapping works. We get a particular value based on the key we're pressing. We're going to use this to move the character forward, and doing this is very easy. I'm going to highlight these nodes and delete them, and instead of print string, I'm going to click the execution pin, drag off, and type add movement input. And here is a blueprint function called add movement input. Now functions are a lot like events. As soon as you fire them off, something happens for us under the hood. In the case of add movement input, our character is moved in a certain direction, and that direction depends on this world direction input. If we hover over this, it says world direction vector. So the data type for this input is a vector. If you're not familiar with vectors, they're simply mathematical quantities that represent a direction and some magnitude. We think of the magnitude of a vector as its length. Think of a vector as an arrow pointed in some direction. Now, whatever direction we're specifying in the add movement input, that's the direction our character will move in. Now, we want to move the character directly forward, and the character class has a function for getting the forward vector. We can right-click and type get actor forward vector. This function returns a vector that represents the actor's forward direction. It's actually the forward direction of the root component, which is representative of the actor's forward direction. So we can plug this right in to add movement input. Now I'd like to control this and be able to move forward and backwards. And we know that axis value is positive or negative depending on the keys we're pressing. Now if we plug axis value straight into scale value, then the vector for the direction of movement will be multiplied by this float value. And when you multiply a vector by -1, it flips the vector around and points it in the opposite direction. So add movement input will receive the opposite direction of the forward vector when we're pressing the S key. So I can compile and hit play, and now I see that I can move forward and backwards. So I'm going to challenge you to make the character move sideways, left and right. So add a move right axis mapping. Go ahead and link up the A and D keys and make sure that A has a scale of -1. use an Add Movement Input node with the MoveRight axis event. And instead of the forward vector, this time get the actor right vector. The name of the function is similar to get actor forward vector. Pause the video and give this a try. Okay, so we'd like to be able to move left and right. So let's go to Edit and Project Settings and scroll down to Input. And here in Axis Mappings, we're going to click the plus to add a second axis mapping. And we're going to call this Move Right. Now I can click the icon that looks like keyboard keys and hit the A key to link up the A key to move right. And I can click the plus to add another key, click the icon, and hit the D key. Now I would like the A key to move me to the left, which is in the opposite direction of the forward vector, so I'm going to change its scale to -1. And now I can close Project Settings, and from here in the character blueprint, if I right-click and type Move Right, now I see Axis Event Move Right. And I can drag off of this and type Add Movement Input. Now for the direction, I want the right vector, so I'm going to right-click and type Get Actor Right Vector, and I have the actor right vector. I can plug that straight into Add Movement Input, and for scale value, I can use axis value. Now if we compile and hit play, I see that I can move around left and right, forward and backward. Excellent. So in summary, we learned about axis mappings and how we can use these to link up keyboard keys so that when we press those keys, we get some sort of value. And we used a built-in function for the character class called Add Movement Input to apply movement input to the character. We used the character's forward and right vectors along with the value that we retrieved from our axis mapping events in order to add movement input to the character. And now we're moving the character. So this is great progress for our character development. We'll continue adding more input capabilities for the character throughout this course. I'll see you soon.